Honors Math 2, Unit 7, was dealing with right triangles, but in actuality, I would also call it our beginning to trigonometry. You basically learned SOHCAHTOA and how to find sine ratios of an angle, cosine ratios of an angle, and tangent ratios of an angle. So when I look at this problem that's on your review, it's number 1 and you have parts A through H. It's going to ask you a variety of true-false questions based off of one triangle. Your final won't be like this. Your final doesn't have 8 different true-false questions. What it has is it has one question that's going to have 3 things that are false and 1 thing that is true. Or 3 things that are true and 1 thing that is false, and you have to find the false statement. It's going to say choose which one of these is false. So this is great practice for a multiple choice test. Just don't expect it to be only true false, because that is way beneath you. You are smarter than that. If I was doing this problem, things I would remind you of. If I'm looking at part B, it says the tangent of G is 12 over 5. We have to say whether it's true or false. If I'm talking about angle G, I'm talking about this angle over here in the triangle. Let me make sure you can see that. Angle G has an opposite of a 5 and an adjacent of a 12. The 13 is the hypotenuse. We learned how to label O, H, and A, but way back in the way Mr. Promo would go, oh, ha, ha, ha. You remember that? I don't know if you do, but I do. Tangent, TOA, O over A is the O over A, 5 over 12. It says 12 over 5. I would say, no, this is false. Things may change if we were to change the angle, though. If we're talking about angle F, then the opposite over hypotenuse, so would be 12 over 13. That would be a true statement because we're talking about angle F. You just have to remind yourself of SOHCAHTOA and how we use it. If you don't remember, you may want to go back to Unit 7 probably 3, I think it is when we learned that. The hard ones, in my opinion, are like letter E. E says HG is equal to 13 sine of G. This is your key right here, sine of G. Well, what is the sine of G? Let me write that down real quick. Sine of G is equal to, I go over here, the opposite over hypotenuse would be 5 over 13. Let me write that down, 5 over 13. That's what I know to be true. Well, let me times by 13 on both sides. If I times by 13 on both sides, then 13 sine of G should be equal to 5. 13 sine of G, 13 sine of G, that matches. So I wonder if HG is 5. Let me check to see, is HG 5? No, it's 12. That must mean that this is false. I'm choosing false because HG is not 5. HG was 12. Those are the kinds of things that you're going to have to do. You're going to have to check Pythagorean theorem. Is it set up correctly? I hope you know how to do that. I think that's what you're going to be using. You're going to be using basically SOHCAHTOA for almost all the problems on 1 and 2. That and Pythagorean theorem. The only thing that you're not using SOHCAHTOA on is problems like number 3. You're still using SOHCAHTOA except it's a 40-degree angle. This is not a 30, 60, 90. It's not a 45, 45, 90. We can't use a special right triangle for this. We got to figure this thing out using our calculator. So I label my angle. They gave me 40 degrees. I go across from 40 degrees. That's my opposite. There is nothing next to your H, but there is something next to your A. That means I must use the tangent. The tangent of what angle? 40 degrees. It must be equal to the opposite over the adjacent, TOA. This is where we need to pay particular attention to two things. First and foremost, is your x in the numerator? You can solve for x when it's up here. If x is in the denominator, I told you back then, reciprocal of both sides. You're just supposed to do that if the x is in the denominator. Here it's in the numerator. Instead of divide by 30, times both sides by 30 so you can get x by itself. And then what you need to do is, since you don't know what the tangent of 40 degrees is as a decimal, we're going to use the calculator for that. We just have to remember that the Casio calculators have a little symbol at the top. The D stands for degrees. If you aren't checking, there is a possible way to be in radians or in gradians, and so if you're not sure, you better become familiar with your own calculator, or if you're using mine, make sure you go under setup and that you see that little D there before you do anything with an angle that's in degrees. And then if I'm plugging in 30 times tangent of 40 degrees, let me see if that's what it says here. 30 times tangent of 40 degrees. I make sure I'm in degree mode. 25.172988894. They must tell me how to round here to the nearest 10th place. 7 rounds that up to 25.2 feet. And I'm using a calculator for those approximations. You'll do somewhat the same thing. You might switch to a cosine, you might use a tangent, just depends. As a matter of fact, that's how you're going to do for A, B, C, and D. But when you get to E, you're going to have to do something that we haven't talked about. When you don't know what the angle is, let's call this a missing angle theta. Sine of some angle theta has a ratio of 0.3907. What does that mean? That means that there is some opposite over hypotenuse of some triangle, and its ratio of opposite over hypotenuse is 0.3907. Well, how do we get that angle by itself? How do we figure that out? You have to do the opposite of a sine. And we call that inverse sine, or it's also known as arc sine. These two things actually cancel each other out. And so if I want arc sine on my calculator of this, I have to press the shift key on my sine calculator. It's very hard to see here. It's in yellow. I can barely see that on the screen. Shift sine. But I bet you could see it up here. See how that says sine -1? Of what? 0.3907. And then some calculators, you better put this end of parenthesis there. Some calculators, the Casios, I think let you get away without putting it there. It's saying what angle has a sine ratio. The angle is 22.998 degrees. That's going to round. What's the nearest degree, the nearest whole number? This is rounding to the 23 degrees. There is something called an inverse cosine. You'll be able to figure those things out. And I think there's actually a mistake here. Let me show you where I see the mistake. E, F, G. Yes, this should be H. And this should be I. And this should be J. And this should be 4J, I think, right over here, 4J. So we use arc or inverses to find missing angles. That's the same thing you're going to do for 5A and for 5B. When I look at 5B, if I don't know what the angle is, I just highlight my angle. I label it using O, H, and A. Opposite, hypotenuse, adjacent. I have an OA right there. I must be using tangent. Tangent of what? Tangent of this x degrees angle equals opposite over adjacent. Well, I want that x by itself. there's a tangent, a trig function in front of it. The only way to get rid of it is arctan or inverse tan. These two things reduce or cancel each other out. So I need to plug this into my calculator, and then notice x is in degrees, so I better be in degree mode, which I am. I'm going to press inverse tan of 8 over 13. You can't see that, so let's see if I can find the light. Oh, there's the light right there. End of my parentheses. It's about 31.6, and it tells me to round to the nearest whole number, so I'm going to say that's about 32 degrees. So the first half of Unit 7 is SOHCAHTOA. How to find angles, how to find ratios, how to use the angles to find a missing side length. There's even a little bit of Pythagorean theorem, and that's what you're doing 1 through 7. But number 8 is actually how that unit began, and these are called special right triangles. There's 2 special right triangles that we learned, and I'm not sure if you remember them, but let's just review just in case you forgot. There's a 30, 60, 90 degree triangle. There's a 45, 45, 90 degree triangle. We learned them because all 30, 60, 90s are in a certain ratio, and same with all 45, 45, 90s are in a certain ratio. What that means is that every 30, 60, 90 degree triangle across from the 30 is going to be in the S ratio. Across from the 90 is the 2S, or twice as big as it. And across from the 60 is S root 3 every single time. We proved that with the Pythagorean theorem. The 45, 45, 90s are S, S, S root 2. And so we can apply that to figure out any of these problems. I'm going to do 8A as my example. First thing I do is I go, okay, I have a 30, 60, 90. Across from the 30 is my S side. Across from the 90 is my S root 2. I'm sorry, not S root 2, it's 2S. Across from the 60 is S root 3. So I just kind of label my sides. And if I want to know what S is, I just use the side that they give me, and I set it equal to whatever is the shortcut says. This says this side is 2S. Well, that 2S has to be the same as the 10 root 3, so I set them equal to each other. 2S is equal to 10 root 3. If I want S by itself, I divide by 2. So in this problem, I know 2 goes into 10 5 times, and so S is 5 root 3. Which tells you, now that you know S is the same thing as X, this side must be 5 root 3. Which would make sense, because if this is 5 root 3 and you double it, that's going to be 10 root 3. But then how do we take that and figure out what y is if the y side is S root 3? Well, plug this S in. Instead of S, plug in 5 root 3 and multiply that by the root 3. Root 3 times root 3 is root 9. Square root of 9 is 3. 3 times 5 makes this side 15. That's the long and short of it. The hardest part is remembering what the ratios are and then using it to find your missing sides. Sometimes you might even have to divide by a root 2 somewhere around the way. So, with that being said, we're going to stop your notes right there just to review, and you're going to have some time to work on these.